Oh yeah, just thought we'd try and kick off our chemistry series, the A-level chemistry podcast. I have to admit I'm not really so sure the best format for these, so please excuse any variations in format, but I thought I'd try the presentation slide first and see how that went with me with the use of the mouse that I've got here. My name is Alistair Leith. I'm pulling in my knowledge of gained from university in chemistry a good couple of decades ago, back in '96. So we're talking about the last century now, but nevertheless, a lot of it still is valid today. So let's go through A-level chemistry. That's what we're targeting. A lot of this will be revision, but it was in a Pearson Edexcel book. So let's see if we could start with the basics and get us up to speed with the A-level, which is what we're in the business of obtaining. Starting off with the good old atom structure, which is obviously can't get any more basic than that, can you? Right, so we're kicking off with helium. Why are we kicking off with helium and not hydrogen? Well, because helium's got a couple of neutrons in it, and I also want to be discussing those. So you know about the structure of the atom in general. You've got the nucleus with the protons and neutrons if it has any at the center. Obviously, hydrogen doesn't have any. Helium does, so that's why helium's here, not hydrogen. So that's the nucleus, and therefore a good watch out. You've got these electrons here which orbit around, and they're not necessarily those pretty colours. I've only got them in there to just representational purposes. In fact, it's not even really to scale, because if it was, well, these electrons would be pretty much going halfway around the estate I'm in. Yeah, but it'd be that big. In fact, if you look at the size of the pardon me, of the atom in general, then you've got if this is a P, the nucleus here sitting in the middle of Wembley Stadium, then these electrons will be circling, going around and around it, right out the outer edges of Wembley Stadium. So if you can picture that. Also with the atom, I'll briefly say it's the simplest state of matter, as far as matter you're used to and you're concerned with. You cannot break anything down to anything more fundamental than an atom. I know physicists will scream at me because you can get electrons, protons, and neutrons, but as far as we chemists are concerned, the atom is the absolute, and that's all we need to be concerned with there. Moving on. More revision as well, I'm afraid. So you've got electrons, protons, and neutrons. So why are these important, and what happens if we change some of them? Well, if you've got electrons, obviously, in an ideal world, the number of protons in the nucleus will balance the number of electrons orbiting the atom, the nucleus, sorry. So if you end up with slightly fewer electrons and you're outnumbered by the protons, you become positively charged, and the other way around. If you've got a bit more electrons than you have protons, then you become negatively charged. And obviously, if they balance out, it's just negative, which means it's just a negatively charged, a negative atom, like helium, in other words. Anyway, moving on. So what happens if we change the number of protons? Well, simply change the element if you start doing that. So if you start off with a single proton at the center, you've got hydrogen. If you go to 2, you've then got helium. If you go to 3, you've got lithium, and so on. So by changing the number of protons, you obviously change the type of element. Neutrons. I don't really want to get you too involved in this at the moment, but let's just say if we change the number of neutrons in the nucleus, you change the isotope. So not the charge of the atom, not the type of the element, but you change the type. You change the type of the atom. So if you're changing the isotope over, you'll get a different type. So for example, if you've got hydrogen with just its proton, stick a neutron in there, you've got deuterium, and so on. So you change the type of that element. You don't change the element. So you've got different isotopes of an element. If that makes sense. Shall I move on before I've bamboozled you too much? You get the general idea, don't you? But as I say, more on that later. Chemists are concerned with the entire anatomy of the atom. Yes, we are. But the main particles we're interested in are protons and electrons. Neutrons, yes, we're interested in them because they change the isotope. But mainly as chemists, we're quite interested in protons, but more interested in electrons. Why is that? Well, it's the movement of electrons which are the cause of the most commonly used word in chemistry, which is reaction. So chemical reactions basically caused by movement of electrons from A to B. So how do we move electrons then? Well, some atoms will lose them, others will just gain them, and of course some share. So that's the way chemical reactions take place. They're either lost, they're gained, or they're shared. And obviously, as a GCSE student, this is probably second nature to you. But again, bear with me, this revision's needed. I won't go into the rest of that slide there. You can obviously pause and have a look at that. But again, just revision. It's probably like listening to paint dry, but we just need to get everybody singing from the same hymn sheet. And of course, oh God, it gets worse, doesn't it? States of matter, solid, liquids, and gases. You know all about all that, don't you? So I'm just going to leave this slide up there for you to have a read. Good cure for insomnia. That, if you've already done it, I'm not going to go over it again. You can see from the diagram, everything's self-explanatory. You are A-level chemists after all. So if you need to revise that, you can. And again, another piece of basics that you're probably well familiar with, the periodic table, which I don't have to hand here at the minute to show you. Basically, it's composed of metals on the left and non-metals on the right. Metals do outnumber non-metals, but we'll be discussing more about that into the course. You've got metals on the left-hand side and non-metals on the right-hand side. So metals are predominantly solid, and then you've got the non-metals, which are predominantly, some are solid, some are gaseous. You've got very few liquids. In fact, you've only got 2 liquids in the entire periodic table. Answers on the postcard as to what they are. I think this is the end of that slide. It is. So I hope that brief one hasn't scared you off, and I welcome you back for the next one. Thank you very much.